we will continue our discussion on IC engine and today I will discuss about lubricating oils, thermochemistry of fuels, thermochemistry and fuels and self ignition characteristics. What do we mean by self ignition? So, before I go to discuss about the thermochemistry on fuels and self ignition characteristics of the fuels, I will try to discuss about the lubrication system and then what are the forces that acting on the piston. So, this is very important. Yesterday I have discussed about the friction and we have identified the sources from where friction is coming, and not only that, rather we have identified the locations where frictional effects are very much important, and how can I minimize the frictional effect by using lubricating oils, and what will be the important characteristics, rather important qualities of those lubricating oils. So, today we will discuss about the lubrication system. This is very important that lubrication system. We have seen that we need to provide lubricating oils to minimize the frictional resistance between two mating surfaces where one surface is in motion relative to the another. So, now there might be three basic types of distribution system. That means we need to distribute lubrications, that is essentially lubricating oil and which are in different parts of the engine. So, there are three basic types of oil distribution system. So, there are three types of lubricating system, lubricating oil distribution system. Lubricating oil distribution system. One is known as splash, we will discuss. Number 2 is very important, pressurized lubricating oil distribution system. And number 3 is very important, that is known as combination or combination of these, combination of above two systems. So, that means we should have lubrication system inbuilt with the engine only to provide lubricating oil in different parts to reduce the frictional effect, and there are three basic types of this lubricating oil distribution system. One is splash, other is pressurized lubricating system, for which we should have one pump to pump lubricating oil in different parts of the engine, and last one is a combination of these two types. That means we can have either both the splashing system as well as the pressurized lubricating system. So, if I discuss that what is splashing system. So, splashing is very I have, when I just at the beginning of this lecture course, in my first lecture probably I have identified other different parts of the SI engine where I have shown that there is a crankcase, rather known as reservoir, and while crank is rotating, by churning action it provides lubricating oils in different parts, so that we should not have, we do not require any external pump to be there for supplying lubricating oil. So, this is known as splash or splashing system. Splashing system, very important, that is here the crankcase is used, crankcase is used as the oil pump, as an oil pump. Crankcase is used as an oil pump in this splashing system, and the rotation of the crank at high speed, rotation of the crank itself distribute oils, rotation of the crank itself distributes oil into the various moving parts, into the various moving parts by splash. That is, the rotation of the crank itself allow rather distributes oil into different parts, and we should not require an additional pump for this distribution system. So, no pump is required, no pump is required, very important. So, by virtue of churning action, we can get lubrication oil in the parts where it is required or needed without any external pump. So, basically small 4-stroke engine use splash distribution of oil, and I mean because only by the rotation of the crank it is not a very efficient system, and it is not possible at all to supply lubricating oil even all the places where we require lubrication oil. So, it is used for small engines, many small 4-stroke engines. This splashing system is used in many small 4-stroke engines. So, this is very important, but a pumping system is required, because if we need to supply lubrication oil in places where it is not possible to supply using only by the rotation of the crank, then we should require one pump to be there only for the pumping of the lubrication oil. So, next we will discuss about the pressurized oil distribution system. Pressurized oil distribution system. So, for this pressurized oil distribution system, rather pressurized lubrication system, a pump is essential. So, oil pump is used to pump the lubricating oil in places where engine needs in places where engine needs lubrication, we have to supply. This is very important, and sometimes this pump is, we have discussed that for the cooling system, sometimes there are two different types of cooling system: air cooled engine or water cooled engine. Air cooled engine means the forward movement of the engine itself allows the air to suck into the engine, and then through the proper path air moves into the engine cylinder, and it tries to cool down the cylinder temperature. On the other hand, there is another system which is water cooled engine, and normally not water cooled, because it is very difficult, because normally if I use water as a coolant, if that engine goes into the places where temperature is very less, then the highly chances are there that water may start freezing. So, sometimes reagent ethylene glycol is mixed with water only to reduce the freezing point, only to increase the freezing point, so that we can use water as a coolant even in those places. So, whenever we are having water cooled system, one pump is there, and so that pump is connected with the crankshaft, I mean engine crank, by a V-belt pulley mechanism, so that we need not to have any external source of power to run the pump. Similarly, the pump which is required for the pressurized oil lubrication system, we can connect that pump in the crankshaft, so that we can, using a V-belt pulley mechanism, so that we can run pump to to distribute oil in the different system. So, pump can be connected, pump can be run using a V-belt pulley system connected with the engine shaft. So, this is very important system. and this is very common that as I said you that most aircraft engines and a few automobile engines use a total pressure system with the oil reservoir located separate from the crankcase. Otherwise most automobile engine, very important that I am telling most automobile engine use dual distribution system and rely on the crankcase splashing within crank splashing mechanism. So, most automobile engines use dual distribution system and mostly they rely on the crank splashing mechanism. On the other hand, in addition to the oil distribution from the by pump, by the pump, right. On the other hand, most aircraft engines and a few automobile engine and a few automobile engines use a total pressurized system, use total pressurized system with the oil reservoir located separate from the with oil tank, oil reservoir with oil tank will oil reservoir placed separately or located separately from the crankcase. So, crankcase itself a oil reservoir, from there the rotation of the crank itself distribute oil into the different parts of the engine when engine is required, lubrication oil. And as I said that most automobile engines are use dual distribution system and that relying on the crankshaft splashing mechanism, relying on the crank splashing mechanism in addition to the oil distribution by pump. On the other hand, most aircraft engines because in aircraft engines it is very important to reduce the friction and they can't rely on the crankcase splashing mechanism. So, they use mostly the total pressurized system and with a separate oil reservoir which is located apart from the crankcase, and a pump will be there and that will be used to distribute oil lubrication oil in different parts. The oil pumps, as I said you that pumps can be connected using a VVL pulley mechanism with engine shaft, or this pump also pumps can be driven electrically, or the pumps can be driven electrically. So, it is not mandatory that the pumps has to run mechanically using the VVL pulley mechanism which is connected to the engine shaft. Pump can also be run using electrically using a battery, fine. So, this is the complete lubrication system which is required for an engine, that sometimes most automobile engine they rely on they use dual lubrication system and mostly relying on the splashing system, so that the speed of the connecting rod or crankshaft, that is what I wrote here, that rotation of the crank itself distribute oil into the various moving parts by splashing or by splash, only by splash, or we can have separate pump and separate reservoir altogether, and that is what we have discussed. So, now we will see that the forces acting on the piston, because we have seen that we get power only in the power stroke, and during that stroke because of the combustion we have we normally we have seen that there is a high pressure and temperature, and that high pressure is creating thrust on the piston face, as a result of which piston is having movement from top dead center to bottom dead center. So, then whenever piston is coming from TDC to BDC, again it is going back from BDC to TDC, that means the force is acting on the piston. So, now we will discuss about forces on the piston, forces on the piston is very important. So, if I try to draw, and to obtain the forces on the piston, we have to draw a schematic, and we can see that during the power stroke. So, we will now draw a schematic that maybe we have a engine cylinder and piston is moving between top dead center, bottom dead center, and so this is piston. So, if I now draw the connecting rod and crank, then so maybe this angle is theta, this angle is phi, this angle is theta, and it is rotating in this direction, right. So, this is connecting rod, this is engine cylinder, and this is crank, or this is crank rotation, and theta is equal to crank angle. So, if this is the x direction and this is the y direction. So, this is the schematic that we have drawn many a times, that when piston is coming from TDC to BDC, then we have a that we can convert this reciprocating motion to the rotary one using a crank and connecting rod mechanism. So, this is the I have used center line as the x axis with positive being down in the direction of piston motion during the power stroke. So, we have used center line as x axis and positive when piston is moving down during power stroke. So, center line we are considering center line as x axis, and x axis is in the positive x axis in the direction when piston is moving down during the power stroke, okay. And y axis is taken in the radial direction, is taken along the radial direction, y axis is taken, very important. And we need to know that what are the thrust force acting in the y direction. So, that is why we have taken. So, and with 0 at the center line, and a radial direction outward taken along the radial direction, and 0 at the center line. So, this is the consideration of coordinate system. So, now a force balance in the x direction. So, if I now do a force balance in x direction, so a force balance in the x direction, it will yield a equation that we need to know. So, net force acting in the x direction, summation of Fx, net force acting in the x direction, that will be equal to m into dup dt where dup dt is acceleration of the piston. So, this is acceleration of the piston, and m is the mass of the piston, mass of the piston. So, m is the mass of the piston and this is the acceleration of the piston, that will be equal to the net force, that will be equal to what? So, I am writing minus F r cos phi plus P into pi by 4 into B square plus minus F t. So, I am writing what is P, where this P, okay, I am writing now. So, first term on the right hand side, first term of the RHS of the right hand side, that is minus F r cos phi. So, what is phi? Phi is the angle between the connecting rod and center line of the cylinder. So, phi is the angle between connecting rod and cylinder. So, and this is very important. So, F r is the force of the connecting rod and F r is the force of the connecting rod. So, if I go to schematic, I can write that the force on the connecting rod is F r. So, F r cos phi minus F r is acting in the direction of the piston in the connecting rod, force of the connecting rod. So, minus F r cos phi is the force of the connecting rod in the x axial direction, rather in the direction when piston is coming down from during the power stroke. So, that is written. So, first term that is written, second term of the right hand side, second term of right hand side is what? That is P into pi by 4, P into pi by 4 into B square. P is the cylinder pressure, because of this high pressure piston will move from TDC to BDC during power stroke. So, this is cylinder pressure, and B definitely is the bore, B is the bore diameter, bore. So, pi by 4 B square is the area. So, P into area, that is the force. And third term is very important, third term of RHS, that equal to plus minus, we have written plus minus Ft. So, plus minus Ft, that is thrust force, that the frictional force between piston and cylinder walls. So, this is frictional force, that is we have discussed last class between cylinder wall and piston. So, because of the thrust force acting on the piston, it will come down, and while it is coming down, we cannot ignore the frictional losses, that is between the cylinder walls and the piston, and this plus minus Ft is this. So, now this plus minus sign is, it depends upon the crank angle. So, the sign of Ft depends upon crank angle. So, when theta is equal to theta less than 180 degree greater than 0, then Ft will be minus Ft. When theta less than 360 greater than 180, then Ft will be Ft plus positive Ft. So, that means when piston is coming between piston crank location is from 0 to 180 degree, then it is negative because it is coming down, and then when it is going up again in the next stroke, that is exhaust stroke, and it will be positive. So, this is the forces. Note that Now, we have seen the coordinate system. So, piston is having movement only in the x direction, but there is no movement in the y direction, because movements in the y direction are restricted because of the cylinder wall. So, movement of the piston is restricted in the y direction, is restricted because of the cylinder walls. So, that means summation of Fy equal to 0, that gives that, of course, force is acting in the radial direction, but the movement of the, because although the forces are acting, the force movement of the piston is restricted, because there is no movement of the piston at all in the radial y direction. So, Fy is 0. So, the force on the force of the connecting rod Fr, so Fr sin phi minus Ft, that is that I mean 0, that gives that is equal to summation of Fy, right, is equal to 0. So, there is no net force acting on the y direction. So, Fr sin phi minus Ft, that will be equal to 0, and if I try to combine these two equation, that is this equation 2 and this equation 1, this equation 1. So, if I combine equation 1 and 2, so this side thrust force, this Ft is given, sorry, this that Fts, where Fts is the side thrust force. So, if I write that when piston is moving, we will have a side thrust. So, this is side thrust Fts. So, this Fts, if I now Fr sin phi minus Fts will be equal to 0, and if I combine equation 1 and 2, so this is the pressure inside cylinder. So, now if I combine equation 1 and 2, so combination of equation 1 and 2 will give that Fts, that equal to minus m dup dt plus p into pi by 4 b square plus minus Ft into tan phi. So, this is the expression of the side thrust force that depends upon the pressure inside the cylinder, frictional forces, and also the acceleration and phi angle. So, I mean, so this is the side thrust force which is acting. This is only because of the rotation of the piston between two locations, TDC and BDC. So, with all this, with this I will now next we will go to I will go to discuss about the some other aspect, the thermochemistry of the fuel. So, we have discussed this. Now, today we will discuss about thermochemistry. I have discussed a little bit this aspect in the context of discussion of carburetor of the system. We have discussed that why we need to know thermochemistry of the fuel. I mean, when we are discussing about the internal combustion engine, rather different aspects of internal combustion engine. Basically, that I have seen that we have discussed that I mean, whether we are providing carburetor or we do not provide carburetor, we need a carburation in a spark ignition engine. But again, in modern days engine we do not require carburation, but we need a modern days fuel injection system, multiple port fuel injection system, MPFI. So, but we need to ensure that the whatever amount of fuel is being supplied into the combustion chamber, and then at the end of the compression stroke we will have a combustion. So, combustion is essentially that there will be a combustion reaction. So, combustion fuel is essentially a family of hydrocarbon, right. So, family the hydrocarbon fuel that during the combustion reaction the hydrocarbon fuel reacts with the oxygen present in the air, and then it produces carbon dioxide, water vapor, and we are getting some amount of heat. It is exothermic reaction. So, reaction is exothermic reaction. So, we need to know the combustion reaction. So, we will discuss about thermochemistry. So, essentially this gives us an information about the combustion reaction. Combustion reaction, very important, that because most of the engines are internal combustion engines, most internal combustion engines get energy from the combustion from the combustion of hydrocarbon fuel with air, with presence of air. So, we need to know that what is the amount of oxygen air required for the efficient combustion of for a particular fuel, and if I need this much amount of oxygen for complete combustion of the particular fuel, then what will be the amount of air we need to supply, because we know that the amount of oxygen present in a particular air. So, to know the history about it, we need to know the combustion reaction, and which we get from the thermochemistry. So, and this combustion reaction, what it does essentially. So, as I said that internal combustion engine get energy from combustion of hydrocarbon fuel with presence of air, and this combustion what essentially does, it converts chemical energy of the fuel into the to the internal energy of the gases within the engine, to the internal energy of the gases within the engine. Right. So, combustion reaction, as I said you that most of the internal combustion engine get energy, because we need power stroke and we need energy. That energy comes from the combustion of the fuel being supplied, hydrocarbon fuel in presence of air. So, to have a complete combustion, because this energy basically you are getting from chemical energy of the fuel into the internal energy of the gas that is there in the inside the cylinder. Now, to get maximum, to maximize the energy conversion, we need to know the combustion reaction, and whenever we are trying to obtain or trying to get maximum energy out of this combustion, we need to know what is the what will be the amount of oxygen required for that in a particular combustion, and what will be the amount of air, that amount of air need to be supplied to supply that amount of oxygen to have a complete reaction, so that we get the maximum energy. This entire history is obtained from the thermochemistry of the fuel. So, and as I said that there are fuel is basically a families of hydrocarbons. There are many, there are thousands of hydrocarbons. There are many thousands of different hydrocarbon fuel component, who will consist mainly of hydrogen, carbon, but also contain oxygen, nitrogen, etc. The maximum possible amount of chemical energy is released from the fuel. That is what I am telling. It is very important that there are thousands, thousands of different of hydrocarbon, thousands of different hydrocarbon, and we will discuss this issue that depending upon the presence of hydrogen and carbon atom, we also obtain different rate of energy from different combustion reaction. So, fuel, hydrocarbon fuel, which consist mainly of hydrogen, carbon, but also contained alcohol, that is oxygen, nitrogen and sulfur. So, depending upon the fuel that is being used, we may get different rate of energy transfer we may obtain. So, the maximum possible amount of chemical energy, so the maximum, as I said that we would like to maximize the energy conversion rate during the combustion reaction. So, the maximum amount of possible amount of energy conversion or chemical energy is obtained from the fuel. So, as I said that since there are thousands of hydrocarbons, so and which consist hydrogen, carbon mainly, and to some extent oxygen, sulfur, nitrogen. So, depending upon the presence of hydrogen atom, also carbon atom, we may get different rates of energy transfer. Not only that, even for a given fuel, a particular fuel, our target will be to maximize the energy transfer rate. So, maximum possible of chemical energy is obtained from the fuel when it reacts. So, when the reaction that is combustion reaction is stoichiometric. That is what I discussed in one of my previous lectures, where we have discussed about the carburation. So, it is stoichiometric, that is chemically correct oxygen reaction stoichiometric. That means that is when fuel reacts with stoichiometric amount of oxygen, that is chemically correct. Stoichiometric is chemically correct amount oxygen. So, this stoichiometric oxygen or chemically correct oxygen is just enough to convert all carbon and in the fuel, all carbon in the fuel to CO2 and all hydrogen to H2O. No excess oxygen O2 is left to produced CO and NOx. So, what is thermochemistry and why we need to know it? As I said that most of the engines gets energy from the combustion of hydrocarbon fuel with presence of air. That is what the conversion reaction does. I mean, it converts chemical energy of fuel into the internal energy of the gases into the cylinder. So, now there are two aspects. There are thousands of hydrocarbon which is having which consist mainly hydrogen and carbon, and apart from there are little amount of oxygen, sulfur and nitrogen. So, the structure of the fuel itself, carbon hydrogen atom, we will discuss in detail that the structure between carbon hydrogen atom, also the number of depending on the number of hydrogen atom, this energy conversion rate varies. So, this is one aspect. So, different fuels will have different rate of energy conversion, but if we have a particular fuel, from that particular fuel, how can we maximize the energy transferred, that maximum amount of internal energy we can get from the chemical reaction, from this combustion reaction, and that information will be provided by the thermochemistry. and that is obtained by supplying only the required amount, that is chemically corrected amount of oxygen, that is known as stoichiometric amount of oxygen during the combustion reaction. So, the stoichiometric oxygen is just enough to convert all the carbon into carbon dioxide and all the hydrogen to H2O, and no oxygen is left, excess oxygen is left to produce CO and NOx. And what will be the required chemically correct amount of oxygen required for the complete or the efficient combustion of a particular fuel? That information is obtained from the thermochemistry, and that is what we need to discuss. We have discussed this issue maybe in the context of carburation and taking an example, but again we will discuss this issue in detail by taking another example, and we will see that what will be the combustion reaction and what will be the corrected amount of oxygen required for the complete combustion of that particular fuel, and that problem we will discuss in the next class. So, with this I stop here today, and we will continue our discussion in the next class. Thank you.